Seen in some magnetic materials, saturation is the state reached when an increase in applied external magnetic field H cannot increase the magnetization of the material further, so the total magnetic flux density B more or less levels off. It continues to increase very slowly due to the vacuum permeability. Saturation is a characteristic of ferromagnetic and ferrimagnetic materials, such as iron, nickel, cobalt, and their alloys. Description: saturation is most clearly seen in the magnetization curve, also called BH curve or hysteresis curve, of a substance, as a bending to the right of the curve, see graph at right. As the H field increases, the B field approaches a maximum value asymptotically, the saturation level for the substance. Technically, above saturation, the B field continues increasing, but at the paramagnetic rate, which is several orders of magnitude smaller than the ferromagnetic rate seen below saturation. Explanation: ferromagnetic materials, like iron, are composed of microscopic regions called magnetic domains, that act like tiny permanent magnets that can change their direction of magnetization. Before an external magnetic field is applied to the material, the domain's magnetic fields are oriented in random directions, effectively cancelling each other out, so the net external magnetic field is negligibly small. When an external magnetizing field H is applied to the material, it penetrates the material and aligns the domains, causing their tiny magnetic fields to turn and align parallel to the external field, adding together to create a large magnetic field B which extends out from the material. This is called magnetization. The stronger the external magnetic field H, the more the domains align, yielding a higher magnetic flux density B. Eventually, at a certain external magnetic field, the domain walls have moved as far as they can, and the domains are as aligned as the crystal structure allows them to be, so there is negligible change in the domain structure on increasing the external magnetic field above this. The magnetization remains nearly constant, and is said to have saturated. The domain structure at saturation depends on the temperature. Effects and uses. Saturation puts a practical limit on the maximum magnetic fields achievable in ferromagnetic core electromagnets and transformers of around 2T, which puts a limit on the minimum size of their cores. This is one reason why high-power motors, generators, and utility transformers are physically large, because they must have large magnetic cores. In electronic circuits, transformers and inductors with ferromagnetic cores operate nonlinearly when the current through them is large enough to drive their core materials into saturation. This means that their inductance and other properties vary with changes in drive current. In linear circuits, this is usually considered an unwanted departure from ideal behavior. When AC signals are applied, this nonlinearity can cause the generation of harmonics and intermodulation distortion. To prevent this, the level of signals applied to iron core inductors must be limited so they don't saturate. To lower its effects, an air gap is created in some kinds of transformer cores. The saturation current, the current through the winding required to saturate the magnetic core, is given by manufacturers in the specifications for many inductors and transformers. On the other hand, saturation is exploited in some electronic devices. Saturation is employed to limit current in saturable core transformers, used in arc welding, and ferroresonant transformers which serve as voltage regulators. When the primary current exceeds a certain value, the core is pushed into its saturation region, limiting further increases in secondary current. In a more sophisticated application, saturable core inductors and magnetic amplifiers use a DC current through a separate winding to control an inductor's impedance. Varying the current in the control winding moves the operating point up and down in the saturation curve, controlling the AC current through the inductor. These are used in variable fluorescent light ballasts, and power control systems. The magnetic saturation is also exploited in the flux gate magnetometers and the flux gate compasses.
Please subscribe and thanks for watching.